You've definitely heard of self-driving cars, right? Of course you have. But what if we took that exact same idea, that intelligent, predictive automation, and applied it somewhere you might not expect? Not to the highway, but to the very heart of your data center. Well, that's exactly what we're going to unpack in this explainer, the pretty fascinating concept of self-driving storage. Okay, so let's just connect the dots here. On one side, you have the sleek, futuristic, autonomous car. We all get that. On the other side, a server rack, the symbol of our data infrastructure. The big question, the one we're going to answer, is how in the world do we get the brains and intelligence of that car into this? So before we can even talk about making storage self-driving, we have to tackle a much more basic problem. I mean, for a car to drive itself, it first has to be able to move, right? And believe it or not, for most traditional data storage, that's a huge challenge. Just think about how typical block storage works. You carve out a volume, you assign it to a specific host, and that's it. Your data is essentially parked in a fixed spot. It was never really designed to be mobile, to just pick up and move to a totally different system. So how do we get this thing on the road? This right here is the big idea. It's called a storage partition. The easiest way to think about it is it's the car. It's this simple, self-contained little unit that holds everything, your volumes, your host connections, the whole shebang. And it lets you treat it all as one single mobile thing. This concept, this mobile partition, is the key that unlocks absolutely everything else. So we have our mobile car, that's the storage partition. Now we need to give it a brain, an AI driver. And just like a self-driving car needs a constant stream of data from its cameras and sensors to see the road, our storage AI needs data to make smart decisions. This whole system, by the way, is often called AIOps, which is really just a way of saying AI for IT operations. And these metrics are basically the AI's senses. It's always watching. Capacity, that's the fuel gauge. IOPS, or input-output operations per second, that's kind of like the raw horsepower of the engine. Bandwidth is like checking Waze for traffic congestion on the highway. And latency is just the round-trip speed. All of this together gives the AI a perfect real-time picture of exactly what's going on. But look, performance is only half the story. The AI also has to understand the business rules. Think of these as the safety features for the data. Does it need local snapshots to protect against cyber attacks? Is it being replicated to another system for high availability? Or does it need a full-on disaster recovery copy hundreds of miles away? These rules tell the AI how important the cargo is. But here's the really crucial part. Knowing all those metrics for this exact moment in time, that's interesting, but it's not where the magic happens. The real intelligence comes from feeding all this data into the AIOps platform over weeks, months, even years. You absolutely need that historical reference to spot trends, to learn patterns, and ultimately to predict what's going to happen next. Okay, so think about it. You wouldn't buy a brand new self-driving car, hop in, and immediately tell it to drive you cross-country while you take a nap, right? No way. You have to build trust first. It's the exact same thing with your data infrastructure. That's why we use this crawl, walk, run model to slowly and safely hand over the keys to the AI. It's a really simple three-step journey, and it's all about building that trust. You start in the crawl phase. Here, the AI is just an advisor. It spots things, it makes suggestions, but you are still 100% in control. Then you move to walk. This is more of a collaboration. The AI suggests a course of action, and with your okay, it does the work for you. And finally, once that trust is solid, you get to the run phase. This is where you can confidently let go of the wheel. Let's make this real. Here's a perfect example from the crawl phase. One of the biggest headaches for any storage admin is unexpectedly running out of space. In this phase, the AI acts like your car's GPS, warning you about a massive traffic jam that's 30 days down the road. So the AIOps platform looks at the historical trends and it predicts, hey, you're going to run out of space here in about 30 days. But it doesn't just sound a generic alarm. It uses generative AI to give you clear, human-readable options. It'll recommend where to move the workload, and it even gives you a compatibility score for each potential destination. But, and this is key for the crawl phase, the human still makes the final call and performs the move. All right, let's graduate to the walk phase and see how this evolves. A super common, everyday task is provisioning storage for a new application. Now, instead of just guessing where the best place to put it is, we can just ask the AI for some help. So instead of you having to go and manually hunt for a system with the right specs, you just tell the AIOps engine what your app needs. You say, I need about 30,000 IOPS, 4 terabytes of space, and make sure it's protected with both snapshots and DR. Now, just like before, the AI comes back with recommendations, and you, the user, still get to choose the final destination. But here's the game changer in the walk phase. Once you click approve, you're done. The AI takes over and does all that complex, tedious work of provisioning volumes and setting up data protection for you. It completely takes the manual labor off your plate. And now for the moment we've been building to. It's time to let go of the wheel. We're in the run phase now, and this is where we empower the AI to take full autonomous control to solve complex business problems before they even become problems. Let's look at the run phase in action with the perfect real-world scenario, Black Friday. The AI, having crunched all the data from previous years, knows that a massive demand spike for retail is coming for one particular system, System A. So way back in October, it formulates a plan. Then in early November, it autonomously and non-disruptively starts moving other workloads off of System A to free up precious resources. By the time Black Friday actually hits, System A is completely optimized and ready for the onslaught. And the most important number on this slide, 0. That's how many times a human had to intervene. This entire, complex, business-critical optimization happened completely automatically with no late-night phone calls or frantic last-minute changes. The AI just handled it, proactively. You see, this is way more than just a clever party trick. It's a fundamental shift in how we manage data infrastructure. I mean, the same intelligence that optimizes for a Black Friday rush could be applied to your company's financial quarter end or a big software development cycle, really any predictable rhythm of the business. So let's quickly recap the main takeaways from all this. First, it all starts with making storage mobile, and that's what those storage partitions do. Second, the AI's brain is fueled by analyzing performance and protection data over time. Third, that crawl, walk, run model is absolutely essential for building trust and adopting this stuff safely. And finally, the ultimate goal here is proactive, autonomous action, letting the AI fix problems before they ever happen. This kind of technology really just opens up a whole new world of possibilities for optimizing cost, performance, and reliability across your entire business. So it really just leaves us with one final thought. If your data infrastructure can drive itself, the only question left to answer is, where do you want to go?